Maybe I'll go through the math and show you why for one of them, then maybe I'll do for both, I don't know. But if you take a circuit like this, let's take in series first. Let's say we have voltage source Vs. We have a resistor called R sub 1. I'll do just few resistors there. R sub 2. You can have as many as you want to, but just to make the process a little bit easier, I'll put 3. This is R sub 3. What I'm asking for is, can I find an equivalent for these resistors where the voltage source doesn't change, the current stays the same, but can you find one resistor we'll call it R equivalent or RT, R total, or equivalent? That will give me the same effect as these three put together. That means the same voltage source here, the same current going through them. So I want the current to be the same and keeping the same voltage source. So these two have to be equal. Well, let's look at that. I assign the current going this way. So this is what? This voltage here we call it V1. The current's going to the right. It's going to mark it plus to minus. V2 plus to minus. V3 plus to minus. We'll call it V here. Let me focus on this side. KVL. Kirchhoff current law, voltage law, not current. Sum of the voltages in a closed loop is 0. This is minus Vs plus V1 plus V2 plus V3 is equal to 0. Do the math. That says V1 plus V2 plus V3 have to equal to what? Vs? How many unknowns do you see there? 3? So I can't solve it. I need to rewrite each V in terms of the current and the resistor. Ohm's law. What's V1 equal to?
IR1.
Yes, I times R sub 1. Very good. What's V2 equal to? Ohm's law. IR sub 2. Yes. What's V3 equal to? IR sub 3. Factor an I out. Now I'll stop here with this one. I want that to equal the circuit on the right. Let's look on the right. KVL again. This will be what? Minus Vs plus V is equal to 0, which means V equals Vs. What is V in terms of I and R here for the one on the right? I times R sub T, right? Since you want these circuits to be equal, that means this piece have to equal to this. This current has to equal to this. The only way the two of them will equal each other if what?
Is if RT equals R1 plus R2 plus
Correct. If R sub T equals R sub 1 plus R sub 2 plus R sub 3. So that's how you find the equivalent of resistors in series. We just add them. So if you have more than one, we go R sub T is equal R sub 1 plus R sub 2 plus ... plus R sub n. As many resistors connected in series, if you add them, that's what the equivalent value is. And if you remember that, you can make life a little bit easier on you. You can shrink the circuit. Now, where can I use that? Here's an example. let's say we have this circuit of 80 volt, ten, 30. Notice this one, I put the shorter side on this end, the longer side. That means it's minus on this end, plus on that end. That's what that notation means. The longer piece is the plus, the shorter piece is the minus. This is 7. This is 5. This is 20. And what do we have? This is the 8. One single loop there. Now, when you're building a circuit like this, you can move things around because it's single loop. It doesn't really matter if you put the resistor first and this one second, or this one first and this one second. It does not change your answer. If I'm looking for the current through that, that will not affect my answer. So if I move them around, I take the 80, I say, you know what, I'm going to move this next to the voltage source. Notice, slide it, the minus on this end, the plus on that end.
Does it matter if we write it like that or in a circle?
Doesn't matter. When you put that, you know, that's like a battery. That's a picture of a battery. Like you take out your calculator, that's what we graph for that. But in terms for our purpose, that these two are really the same thing. That's just an independent source. It does not have to be a battery. This could be just a power supply that gives you a DC value. But that's a picture of a battery. But for the purpose of our calculation, no, they're the same. What's the difference between them in real life? This is supposed to be always 80 volts regardless what time you use it. When it's a battery, what happens after a while? Drops a little bit there. Then it dies, you know. So this will not supply power the rest of its life there, you know. But in terms of our calculation for our purpose, yes, they're the same thing. I'm going to move that source here. Notice the plus on the top, the minus. I'm going to slide it all the way next to this. Now put the rest of the resistors. So I just move things around. Now look at these 3 resistor, 4 resistor, whatever, how many of them there. How are they connected?
In series?
Yes. So to find the equivalent value, RT, what do? We add them. Doesn't matter if you're on the top, here, or here. Will not change your answer. 7 and 8, 15, 20, 30. Now the question is, what will happen here to these sources? Can we really combine them into one source?
Yeah.
How?
Add them.
Can we add them?
One of them's going to be a negative.
Well, just think about this. If we did KVL here, this will be what? Isn't that a minus 80 the way we do them? Minus 30 plus 20. I'm only interested in the sources. Plus the V here, we'll call that V. Can you combine the math here? What's minus 80 minus 30 plus 20? Is that a negative 90 plus V?
Yeah.
So that means I can add these voltage sources. I can replace them with one value of equivalent to 90 volts here. Because if I do KVL here, I'll have what? Negative 90 plus V. So when you have voltage sources in series, you can combine them. You either add them or subtract them. It depends on the direction. So if you go minus to plus, then minus to plus, that's the same direction. You adding them. But if you go minus to plus, then the next one plus to minus, what's going to happen? You need to subtract them. You can see that from KVL. This is minus 80, that's plus 20. That's going the opposite direction. I'm going this way, minus to plus, but this is plus to minus. I need to subtract them. So that's the equivalent of that circuit. Now if I want to find the voltage or the current through them, I'm done. You want to find the current I? Ohm's law. I equals what? Or V equals I times R. The voltage is 90, they're in parallel. The current is I, the resistor is 30. What's I equal to? 3 amp. And if I need to find the voltage across any one of these, what was the voltage drop? This will be 7 times I. 7 times 3, 21. What's the voltage here? 5I. 5 times 3 is 15. What's the voltage across this one? Plus to minus. It's going this way. 8 times 3, 24. What's the voltage here? Plus to minus. Plus on this end, minus on that end. 10 times 3, which is what? 30. Ohm's law. Okay. How about combining resistors in parallel? In parallel. Let's take a circuit, go through it, and combine the resistors in parallel and see what will happen. Derive an equation for that. So I have a current source, I sub S, and I'll just use 3 resistors, R sub 1, R sub 2, R sub 3. And again, I'm trying to replace that with one resistor, we'll call it R sub T, in parallel with the same source, I sub S. So this has to equal to this. Now, if I call this voltage Vx, then this has to be Vx. So can you find, oh, R sub T, not 2, total. Let's find an equation. Let's see how we can find the equivalent of these 3 resistors and replace actually these 3 with one resistor right there. Let me define current coming down, and again, the reason I'm making the current coming down, I have plus to minus voltage across each one of them. Plus on the top, minus on the bottom. That says, you know what, probably that current's going to be coming down. This is ground here, so that doesn't count. There's only one node on the top. KCL at the top. Let's look at the current at the top. What is going to that node? What's going in?
I sub S.
I sub S. What's leaving that node? I1, I2, I sub 3. Can't solve that. 3 unknowns, 1 equation. Let's think about I sub 1. What is I sub 1 equal to in terms of Ohm's law?
Vx over R1.
Vx over R1. Very good. And what's I sub 2?
Vx over R2.
Vx over R2. And I sub 3, Vx over R sub 3. You can factor the Vx out. What do we have? 1 over R1 plus 1 over R2 plus 1 over R sub 3. Let's look at the right side now. Just looking at that equation, what is I sub S equal to? They're in parallel here, right? It's the voltage divided by the resistor. What's the voltage here? Vx, and what's the resistor? R sub T. Ohm's law. Which means I sub S equals Vx times 1 over RT. Again, you want this side to equal to this. Here we go. You get I sub S here, you get the same I sub S here. You get Vx here, you get Vx here. For these two to equal each other, that means what? These resistors, the sum of them must equal that one. 1 over R sub 1 plus 1 over R sub 2 plus, if you have R sub 3, 1 over R3. If you have more than that, should equal 1 over R sub T. So that's how we find the equivalent of resistors. 1 over RT equals 1 over R1 plus 1 over R2 plus 1 over R3 and so forth. Now, if you only have two resistors, there's a shortcut to that. Anyone remember that?
Multiply R1 by R2 and then divide by R1.
Yep, the product over the sum. If you only have two resistors, watch what happens. Let's watch the math. I want to solve for R sub T, right? This is an equation. I don't like fractions. I never liked fractions. So let me multiply every single piece here by what? By the LCD. What's the LCD?
Lowest common denominator.
Which is R1, R2, RT, right? So if you multiply every one of these by that, you will have R2, RT plus what? R1, RT equals R1, R2. Notice I can factor R sub T out. If I factor R sub T out, what's left? R sub 1 plus R sub 2 equals R sub 1, R sub 2. So what is R sub T equal to? R1, R2 over R1 plus R sub 2. We call that the product over the sum. Now, you can only do that when you have two resistors in parallel. If you get three, that does not work here. It's not going to be R1, R2, R sub 3 over the sum of them. It will not work. So what would you do if you have three of them? Let's say we have this one, 12, 12, and 6. I have two options. I can say, well, wait a minute. I know the equation, 1 over RT equals 112 plus 1 over 12 plus 1 over 6. That's 212, 3, 412, right? Which is what, 1/3? So 1 over RT equals 1/3. What's R sub T will have to be? 3. That's one way of doing it. Or, if you want to use the product over the sum, you can take these two, do them separate, multiply them, 144 divided by 24 which is 6. So we did these two to get 1. Now take these two, do the product over the sum. What's 6 times 6? 36 divided by 18. 36 divided by 12, which is what? 3. So if you got more than 2 there, you can do 2 at a time, product over the sum, and keep reducing that. Here's a little hint. He said, how'd you do that so quickly? When they are the same value, when you do the product over the sum, the answer is always going to be half that number. Always. So if you have 10 and 10 in parallel, what's half the 10? 5. 8 and 8, the result is 4. 9 and 9, the result is what? 4.5. It's always half of them if they are equal. So when I was making the problem, I said, oh, let me make this easy. 12 and 12, that'll make it a 6. Then 6 and 6 will make it a 3. That's how I came up with that problem quickly in my head. And you can take advantage of this. I have time for one more example. Because you can combine things and make the problem much easier instead of dealing with an ugly problem. Here's an ugly problem. Watch how quick I'm going to simplify it. Only got 5 minutes, but I'm sure we can do it. When you look at it, it looks like, oh boy, it takes 5 minutes just to draw that picture of it. .9, God, they're killing me with these values. I sub 3. And I sub 3 happens to be this current. Then on this end, I got 15. 6 and 6. Four. I just want to show you quickly. We can take that, and it looks ugly, but color calculation here, and we can shrink that. I don't know what we look, doesn't say what to look for. Let's say I'm looking for, I don't know, I sub 3, whatever the case is. But if you look at these two first, how are they connected? Parallel. What's the value of them?
3.
Half of that number when they equal. So these will have a value equal to 3. 3 in the 15 will make it what? 18. So let me redraw that. And you know what? That 18 is going to be in parallel with this and parallel with that. I can put it right next to this. And if you look at that, that's where? That's attached to the top and the bottom. I can put it right here if I want to.
Could we do the same for I3? Move it to the left side if you wanted to.
I sub 3, do what?
The current. Move it to the left side.
Here?
No, not on the bottom picture.
Source.
The bottom.
Yep, 0.9.
Oh, move it down here, you mean? I could, yeah, sure. Yeah, I could. I will in a few minutes. I'm trying to put like the similar one next to each other. Notice these two in parallel. The product over the sum. So if you have a calculator, quick way, 9 times what? 18 divided by what? 27? That's a 6. And that would be what? A 2 here, 6 up, 4 down. KCL says add all the current going in equals all the current leaving. The math actually, this would be 6 on this side, that would be 4 on that side. What's the net result? 2 amps going up. Oh, almost done.
Over today?
Yep, I'm done. Just 2 minutes. Now, does anyone notice why I'm not going to combine this with that one? Did you notice? I didn't combine them.
Because you need to find I sub 3.
Exactly, I'm looking for I sub 3. If I combine them, I lose it. So I can leave it like this. And now that's my circuit. That's it. So I can do KCL at the top. The current going in, what do we have? I'm not sure about this current. I'll make it coming down. I sub 4. What's the current going to that node? 2 plus 0.9 I sub 3. And what's leaving that node? I sub 3 plus I sub 4. 2 unknowns there. But they're connected how? In parallel. They have the same voltage cross them. What's the voltage cross them? Let's call it Vx. So here we go, 2 plus 0.9. What's I sub 3? Vx divided by 3. What's I sub 4? Vx over 6. How many unknowns you see there? 1. You solve for Vx. And once you have Vx, you have everything. But notice, we took that circuit, replaced it with this, which is much easier to handle. I'll stop. We passed the time.